All right, well, you guys are back from the break. Hopefully you had a restful break. Um, Tried to be restful during mine. It didn't go quite as expected. So, um, this week we're starting into what some people find easy and some people find hard. It all depends on how your brain is wired. Um, we're going to be talking about joining tables during a query. So far, you guys have had to write only ever involved with table. You're either doing an aggregate on a couple of columns, but you're doing X with wheres, but you only ever involved one table. Now, what's the point of having a relational database if you can't pull from more than one place at a time? And this is where joins come in. Now, the slide deck has all kinds of reference and that kind of stuff, but as you guys have experienced, there's not that much time to cover both the slides and showing you guys. So definitely recommend reading through the slides. So the slides talk about that there's two styles of joins. There's the old style, known as implicit joins. So when you go and you search on your preferred search engine, whether it's Google, Bing, DuckDuckGo, whatever you use, and you search for how to do a join, often you'll get examples showing the implicit manner of doing joins. Hey, get the door. And I'll demonstrate what an implicit join looks like, and then I'll show you the modern way and explain why the old way of doing things. Uh, so just so you know, I posted an announcement earlier that with a database you could have installed if you tried to follow along. That's it. Um, database. Um, it's actually real flight data from about 10 years ago. So it's real airports, real routes, real aircraft, real everything. Uh, so why is that not resolving? There, because it decided to forget which one I was using. There we go. So let's just say I wanted to pull, actually, let's go like with this from airports. Okay, so I saw for the break, and here's your results at the bottom. Here's all our airports. However, let's just say I want to have the airports and the countries. So if I go look at the implicit way, you do countries where airports country ID is equal to countries dot ID. And helps if I don't have the semicolon here. Okay, so if I run this, it's still going to run just fine. Now I've got countries and the airports. Now you'll notice a few interesting things in this particular query. I'm using the column called name twice, but I am giving it a prefix. It's known as the table prefix. The table prefix says, I want you to grab the name from this particular table. Now, like I said earlier, this is known as an implicit join. You'll see right here that you've got a table, comma, another table. In theory, you could have 5 or 6 tables, all comma delimited here. And then if I ran just this would work just fine. But the problem is that it will do an implicit join, also known as a natural join, where it tries to find matching column names and just maps it across that way. That's totally pointless because, well, there's no point doing it like that because it doesn't mean anything. It's not actually connected properly. So you'll see in the where clause here that I'm mapping what the relationship is between the two tables. So in the countries table, there's a column called ID. In the airports table, there's a column called country ID. So if you remember before the break when I talked about foreign keys, all the values in country ID must exist in the ID of countries. So for every country ID here, it maps out to one country here. So when I run it, it then maps out properly like each of the countries based on, country to airport. Now this is known as an implicit join. And this is, when I went through school, this is how we used to do joins, just so you know. Um, the modern method of writing joins was just on the drafting board. It wasn't even released to the public. They were still arguing about how to do it. The problem with implicit joins is that you had to use some really strange syntax to do some more fancy joins, and not all the database servers did it the same way. And the other issue is it will pull all the records from airports and countries before it applies the where. So that means it's loading everything in memory and then mapping it. So it's going, okay, now in memory, we're going to sort through the list of records and then we'll make the connections after the fact. So it's not as performant. Like most database servers, you'll never notice the difference. I'll be honest. You'll never notice the difference because they've gotten really good at handling this. However, 20 years ago, man, I'm old. 20 years ago, finally, the modern join syntax came out. More than 26 years ago. And the reason, explicit and by default, explicit as joins. Do not take the query I just created. I'm going to rewrite the modern syntax. So the good news is I can be lazy and grab. Okay. Now the modern syntax actually uses the keyword join. Technically, I'm doing so I could actually say inner. It's a thing. The word inner is optional. Is that the default type of join? So if you don't tell it's an inner join, that's what it's going to do. So now trees, instead of it happening in the where, explicitly here how it connects. And it's really nice because it understands the database structure and it finishes it for you. So you can see that this is exactly the same as this. However, the collation of the records happens as part of the record pull, not after the records have been pulled. So it happens earlier in the process. So if I run this, it'll give me the exact same results like as the one before. I mean, it runs in 163 milliseconds. Let's go see if it is faster. This one ran 71 milliseconds. You know why? It's cached. Database server remembers that I ran this. I don't need to do this again. I've got this in memory. Another reason why database servers are really quick. Yeah, you actually have to wait. It clears itself. Okay, so one of the other items that we have to take into account. I know we're doing countries and airports, and we're grabbing the name, which is cool. Except depending on the database engine you're using, this might just return two columns called name. MariaDB returns airports.name, countries.name. If you did this in MySQL, it would return name and name. If you did it in Oracle or Postgres, it would return name and name. So remember I spoke about something called aliases before the break? So I can go as country. Now I've got uniquely identified columns. So that's one of the big perks of the aliases. The other nifty thing is you can use aliases to rename the table temporarily. So for example, if I want to be really lazy and I don't feel like typing the word airport out the whole time, you can give them an alternative name and then just use the alternative name in the query. So be aware, this is a temporary rename. This rename only exists for the lifetime of the query. So You execute the query, the table gets, it's not a, so it's the exact same result. There is no difference. Um, I don't tend to use table aliases very much personally. I tend to prefer being very explicit with my table joins, even though it's more typing. But as you can see, the ID takes care of a lot of it for you anyways. Um, Depending on your database structure, you may end up with tables that have very similar names, but you'll end up using acronyms like AC, AB, and then you're like this far into the query and you're going, what the heck is AB again? So if you use the explicit names for the tables, you'll remember what it is you're working on. So it's a matter of preference. That's all. I will often use aliases on my return on the select section just to make the output more manageable to work with, especially when you're working with um, running queries from inside of a program, like whether it's Python, PHP, Java, whatever. When the results come back and you have ambiguous column names, it usually operate as if it was an array, which I don't know if you guys even have learned about arrays yet or not, but basically a list of values that are identified by a key. What happens if both keys are called name? So usually you want to do aliases so that where you're working with your application, your code, you actually have nicely named columns. Um, all right, so that's the aliases the side of the deal. Um, Now I'm going to expand on this, and I am going to connect um, an airport to an airline. Because you can join multiple tables. Obviously, I joined two. What's the difference between 3, 4, 5? There is no difference. You just have to keep track of what it is. Any other program you write, and it's not a program. Just like when you write a program, you don't write 1,000 lines of code and hit run. You tend to build it up. You write a little bit, you make sure that works. You write a little bit more, sure that works. You add a little more, suddenly everything breaks. Probably it's whatever you just added, right? So when you're joining create queries, you tend to want to build it up. So I am going to join. I'm going to start with this existing query. So tree name, and I could do this join. Um, so I could go lines. It's airlines and airports, eh? They're both A. So I'm just going to make everything. Get rid of that. Get rid of this. So I'm going to connect via the country, and I'm going to get airlines.name as airline. And now I'm pulling ports, airlines by country. This isn't a particularly query because all it's doing is it's matching up basically every airport and every airline that shares a country. It doesn't really mean that that airline actually flies in and out of that airport. It just means they share a country. So this is treating a bit how you can do a join that works, but it might not actually be useful. Um, you just have to work around it and figure out how to make it useful. Um, but as you can see, you can just join whatever you want. Realistically, what we'd want to do is we want to go inner line root source, and then we want to go uh, Really interesting how, as I change my query, that the order of the records change. Because as I join stuff up, it starts changing the order of stuff. Now, what is happening here? Pulling the airports. I'm joining the countries to the airport, so we know what country the airport operates out of. We're joining routes, and then I join airlines. I might actually take the countries out of this because it's just going to make things more complicated. Let's get rid of that, like that. Okay, so in this database, in the routes table, there's two airport IDs. Destination. Source when the plane takes off. Destination is when the plane lands. Saying, give me all the airlines with routes that with start there. So essentially, go grab. Some of these aren't really unique. Peru has routes that starts in, you know, all of these getting repeats because there are multiple routes taking off from that airport for that airline, right? One might be going to, actually, let me go where, uh, airports dot name is equal to, I misspelled Pearson? I thought so too. Airports, routes, source. Yeah, there's lots of that. Okay, let's try McDonald. Nope. Okay. Inner there, I'll find Toronto in here somewhere. I was trying to pick out Toronto's airport. As well go with Canada. So essentially, you know, I'm saying give me all the airlines that have a route that begin at an airport in Canada. As you can see, you can slice and dice these queries. There is a golden rule though. You cannot join a table to another table that is not listed before it. So remember before the break, I talked about how queries operate from left to right. Carriage returns are ignored. So technically, this is left, this is right. So when we say that it can't operate with a that doesn't exist, it means that, for example, you can't join anything to airport unless airport is in the list. So I will grab this one here and I'll drop them. Me. I got an error message. It says unknown column routes airline in on clause. And you notice it made the routes go red. It doesn't know that the table routes is even available to it because it's not in the list before it. So you join, doesn't make a difference which direction you start in when you're joining tables, like you start at the end, start at the beginning, but you always, if ever you join a table, you always have to make sure you join to a table that's already in the list. So in this case, we can go airports to routes, routes to airlines. I'm joining countries and I can put countries anywhere I want because airports is above it. Um, so this gives me all of these ones. Now I'm wondering where Toronto is. Amble River, Vancouver. Actually, let's go, let's make this distinct so the lot shorter. Lester B. Pearson. Yeah, because that's what it is. We just call it Pearson. Yeah, but it's Lester B. Pearson Airport. That's its that's its real name, just like Ottawa McDonald Cartier, um, or Pierre Elliott Trudeau. You know, we just call it the Trudeau Airport. Montreal. That's the big airport in Montreal. It's brutal. It's a sucky airport. I've flown in and out of there a couple of times, and I had to grab a transfer, and it was at the other end of the terminal. And the Montreal terminal is not as big as Pearson, but it's not as well organized as Pearson. And I actually had to get on a tram belt. So they actually had like accelerated floors where you get on it and you walk and you're like flying. And it actually picks up speed because there's different belts. As you get to the middle, it gets faster and then slows down the outside. Yeah, yeah, it's lots of fun, especially when somebody you're traveling with is in. Yeah, that Montreal they do. It's awful. It's an awful airport. Yep. They yeah, they don't do that anymore. Yeah, it's too much. Yeah. So these are standard joins, known as inner joins. This the bog standard join. This is the kind of join you'll use 99% of the time. Like guaranteed 99% of the time, this is what you need. Every once in a while, you'll need a left or a right join. Now, left and right joins, I'll demonstrate what it does first. Actually, I'm just going to grab starters like that. And I don't need airlines. But I'm going to grab the route ID just for argument's sake. Okay, let's make sure my query works before I change it. Cool beans. Oh, left join. Uh, yeah, because I have the word inner. Duh. There we go. Okay, left join. Um, and that's probably going to be fine. Let's go this one. Okay, this is going to work. Now, doing now, I'm connecting airports to the destination. In other words, or plane landing. What left join means is it says, give me everything ports, only matches from routes. So you'll always get all of the airports, but you might not always get matching routes. Now, when we're talking about airplanes, it's kind of scary when you think about a plane that can go up, it never comes back down, right? But if you are applying this in a business sense, it's a query we use in business a lot. When, for example, you want to know what products haven't sold. So if you know Amazon's got billions of products listed, there are products that have never been sold, not a single time. And once in a while, they'll run a thing through their catalog to start identifying which products have never sold. So in theory, you could do a select star from products, left join order lines, and it would give you all the products and only matching order lines. And at that point, you're still saying, well, we're still getting all the products. However, if I go where our routes.id is null, suddenly you give me the airports where a flight takes off but never lands. These are airports where there's flights that do private charters that could take off from an airport. And for example, they could be float planes. They take off, land on an unmarked lake, drop people off, and come back. Same airport, but they don't have an official airline route, so they can take off. Some of them are tours. You know, we take off, fly around, land back to the same place. When this database was created, it never actually they never made a landing at the same place as an option when they made the data for this database. But it is what it is. So in this case, we have airports where planes take off and never land. Um, so you'll notice right here, I did is null on the routes ID. So when you do a left join, it returns everything to the left. Again, what's to the left of routes? Airports, because we read from left to right. So therefore, it'll give me everything in airports, and then any matches it finds in routes. If it doesn't find something in routes, it will return null values for those columns. So I could turn this routes ID into routes star, just so you can see, and you can see that the entire row is null for the routes. So it returns nulls. So if you want to find out where, there's rows in one table that don't have matches in the other, you can actually use is null, and magically, you now know which row, which airports have whatever. If you're applying it to business, you could say, oh, this list of customers that haven't ordered anything, especially if you put an aware clause that says only orders that are, say, you want to find the clients that have not ordered anything in a year, you could do this with a left join and then adding, an order date. There's all kinds of things you can do left joins with. It's just not one you use regularly. Normally, you're using it for a special purpose where, like I said, you're trying to find records that don't have matches, or you have records that can be not set yet. For example, you place an order from a store, but they don't know what shipping method they're using right away. Most of the time you order something online, they pretty much have one shipping method, right? Not everybody is Amazon, where you end up one of random, 5 different companies that can throw the stuff on your front step. They don't deliver it to the that's why I have a camera. I mean, oh yeah, I had something damaged about 2 weeks ago. The guy literally drifted from the middle of my driveway. It's probably a 20-foot throw. And the thing was made out of glass. So I also blame the guy, the person who packed it at Amazon, because big box, the thing was this big, and they put one little piece of paper in it with it. So, it's not great. Um, so yeah, left joins. A right join just does the opposite. It'll give you everything from the right and potential matches from the left. Right. So back to my example of shipping. So for example, if we want to pull out all the orders and we don't know how it's shipped yet, but we still want to see all the orders, you could pull it and then also have a left join or right join is applicable for the shipping method. That way you could see the orders that actually have a shipping method, but if they don't have a shipping method, then it just won't show it because it hasn't been shipped yet or the method hasn't been selected. There is purposes for left and right joins. It's just not one you use quite as often as the regular joins. Okay, so the next item is natural joins. And the problem with why I discuss natural joins, and I usually don't do demonstrations of it, is you need a database designed specifically for it. And proper database design, depending on how you did your design, natural joins will never work. If you follow modern database naming conventions, if you're following like what was popular 30 years ago, natural joins would work. So what is a natural join? A natural join would be, I wrote it like this. Notice I'm not telling it how to do the join. What it does is it looks for columns that have the same name. And then it goes, I am smart. You have 2 columns with the same name. That must be what I'm supposed to join on. So then you just run it and you get something. Just happens to be there's 2 columns called ID. So it's joining across the IDs, even though the IDs are not the foreign key. Now, if you're using a database where the columns are named in such a way that, customer underscore ID is the primary of customer, and the foreign key is also called customer underscore ID, the natural join will do it. It'll join across the matching columns. It will work, but it means your database has to be designed. So not sure what I just lost, but I don't think I lost that much. I saw the pop-up up there. Um, so if you have a table that has the same call, like joins multiple times to the same table, so table A joins table T2 twice, as in source airport ID, destination airport ID, natural joins won't work on that, so you still have to use explicit joins. Um, Realistically, you always use explicit joins. You should never let the computer assume it knows what it's doing, because it's going to do exactly what you told it to do, but not necessarily what you want it to do. Think of this as a small child, or that friend we all have that's not too clever, where you tell them to do something and they'll do exactly what you told them to do without actually thinking whether or not what the steps are. The database server will do the same thing. Just always be explicit with your joins. Natural joins are not your friend. Like I said, might work in databases from years ago, might even work in modern databases depending on who creates it. For example, one of the people I work with, he's an old school database designer. He's been designing databases for 40 something years. He uses the old naming conventions, and you will pull those old naming conventions out of his cold dead hands before he ever gives them up. He refuses to change his naming conventions. It's like, cool, it's your database, you do whatever you want with it. I'm not going to argue. There's been, I mean, that's just what he's done for 40 years, so why would he change? Whatever. It works. He's the one who has to work with the database, not me, so cool. All right. So the last type of um, join is known as a Cartesian join or a cross join. Um, Occasionally you'll come across it referred as a matrix join, but that one's really, really rare. I think it's usually a linguistic thing where it was translated in somebody's language and they brought it back to English and it really doesn't line up. So how many of you took Cartesian sets in high school? Does that ring a bell? Okay, so they don't really teach the concepts of sets in high school anymore. When I went through high school, we actually had specialized math courses where after you did, a grade 9, 10, 11 math, you could grade 12 math, then you could take specialized math courses like a trig course or a um, geometry course. Calculus was another one. But these ones you'd find something in a program called finite math. So Cartesian sets are basically sets that involve all values in both collections. My database already exists for this, so I'm not want to give it to you guys for when I post this sample. Join joins every value to every other value in a table. And you'll notice that it looks like the exact same thing as a natural join where we're not specifying any columns. However, the difference is there are no matching column names. So what does it do? Is it goes table 1, item 1, match it to every item in table 2. So I'm basically doing a small deck of cards for you. So we have face values, 1, 2, 3, and we have the suits, diamonds, spades, hearts, and clubs. And then I'm just going to select from those two tables, and I'm in the wrong database. Hang on. Switch to this one and run this. And now you'll see that I've got diamond 1, diamond 2, diamond 3, spades 1, 2, 3, hearts 1, 2, 3. So basically it lines up every row to every other row. Now, I'll be honest, in my career, I've never used a Cartesian join. Doesn't mean there's no purpose. Otherwise, if there's a purpose, they wouldn't have created this process. It's really good if you're trying to build up a matrix of values. So let's say you have a lot of potential options for something, but you want to be able to put it also because then they can run reports against a denormalized version of all these options. You could do it that way using a Cartesian join. There's a big danger with the Cartesian joins though. Table A has 1,000,000 rows. Table B has 1,000,000 rows. What's 1,000,000 times 1,000,000? So if you did a Cartesian join on two tables, 1,000,000 rows each, you end up with it's a trillion. Yeah, depending on how your country describes numbers. So yeah, you got your millions, billions, thousands of millions, or a trillion. Um, it's not your friend. Normally, it's going to be done with matrices of products and their options. So you can see like every product with every option. So t-shirt size small, t-shirt size medium, t-shirt size large, and you want to have one row for each of those options. Oh yeah, you'd run out of memory. Like the server would just go, no. Like, what are you doing to me? Um, one of these days I'll generate a database big enough to crash my laptop. But it would take a lot. All right, so these are the most common types of joins. Um, like I said, the biggest thing you have to do is is there's three things you have to remember when you do joins. One, you have to join across the foreign key. Technically, you can join anything to anything else. It doesn't care. The database server will do exactly what you told it to do. But what's the point of joining across airport name to country name or airport name to airline name? It's not a real point of commonality, right? So, but airport to country has a point of commonality, which is the country ID. So that's item number one. For it to be a useful join, you want to join across a point of commonality. Two, make sure you join them in the right order. You'll get an error message if it doesn't work. Just be aware, learn what that error message means, because I've been doing it for years and every once in a while I'll still make that mistake. Um, Number three, only pull what you need. So for example, if I grab that really chunky query right here and I take off the distinct, actually I'm going to grab it, keep it, and just say, give me all the things. Okay. And I'm going to run it. It came out really fast. Um, I really wish I could get it to tell me how expensive that was. Does it have an option for the explain? If I was using a different editor, there's explain. There it is. Okay, so you can see right here, the explain is really cool because it shows you what the steps it takes to figure out the query. And you will see that how many rows are pulled from each one. This really isn't giving me the actual performance or how fat it is. Um, Actually, I know how to show you the difference. If I go run and then I tell it to ESV and put that on my desktop. Okay, export to file. Now I'm going to run this one and I'm going to export that one to file also. Okay, here we go. So 38 and 40. 38 is the select star, 250K. No, wrong thing. This one is I want to go properties, 12K. That's a really big jump in the amount of data being transmitted. Now, the thing is that these two tables are pretty small, right? Like 50,000 rows of data is not really that much. But imagine you're working on really big rows of data or huge tables with, millions of rows of data. This number will just grow exponentially with the amount of data you're pulling back. So be very selective, and that's not a pun, even though we're doing selects. Be very selective with your what you decide to pull back because it will impact performance because you're going to pull back a lot more than you really need. And at the same time, you're punishing the database server unnecessarily. And you're going to be adding overhead for everybody, not just yourself. So that's joins in a nutshell. The slides do have a little more detail on a few odds and ends. But overall, this is the important one. And honestly, this example is the one that has everything you need in it. It has an alias. It has joins multiple tables. It's got a where clause. It shows you pretty much everything you need for the lab in this one query. All right. Outside of that, the labs should be visible to you guys, I hope. Labs aren't visible yet to you? Okay, hang on here, Russ. I'm just going to stop the recording because I don't need to record